Air defense is the shield that makes everything else possible for Russian forces in eastern Ukraine. Without it, Ukrainian strike drones and artillery observation assets operate freely. Without it, the Russian rear area that logistics, command posts, and heavy equipment depend on becomes a targeting environment rather than a sanctuary. When that shield fails, when a specific air defense system is located, tracked, and destroyed, the gap it leaves is not just a gap in the radar picture. It is a gap in the operational architecture that Russian commanders have built their entire rear area security around. In the middle of April, through a combination of fog, patience, and the specific skills of Ukrainian reconnaissance teams operating in terrain that the fog itself was helping to conceal, that is exactly what happened. A Russian Buk-M2 surface-to-air missile system, one of the most capable medium-range air defense platforms in the Russian military inventory, a system that had been providing anti-drone and anti-aircraft coverage over a significant section of the Eastern Front, was located, confirmed, and destroyed in a coordinated strike involving Ukrainian reconnaissance personnel, drone operators, and artillery. The gap it left in Russian air defense coverage opened a section of the operational area to Ukrainian strike assets that had previously been constrained by its presence. This is the full story of that engagement. The Buk-M2 had been a problem for Ukrainian operations in the sector for several weeks before it was destroyed. Its radar coverage and missile engagement envelope had been limiting Ukrainian drone operations over a specific section of the front, forcing Ukrainian drone operators to route their assets around its coverage area, reducing the observation quality in the sectors it covered, and preventing the use of Ukrainian strike assets in the airspace it protected. Russian commanders who positioned the system had done so specifically to constrain Ukrainian air activity in an operationally sensitive area. The area above and behind Russian positions where Ukrainian drone observation of Russian logistics and command activity would otherwise be continuous. Ukrainian intelligence had been developing the Buk-M2's approximate location through electronic intelligence collection, monitoring the radar emissions that the system produces when operating in search mode, and using direction-finding techniques to narrow the location to a general area. Electronic intelligence can establish that a system is operating and can develop a directional bearing to its emissions. But establishing a precise location, targeting quality coordinates, typically requires additional collection from different angles or visual confirmation from a drone or ground observation element. The mid-April fog that settled over the eastern Ukrainian terrain in the early morning hours of the engagement day was the environmental condition that made the visual confirmation operation possible. Dense morning fog in eastern Ukraine, in the mid-April period when temperature differentials between the ground and the air create persistent low-level fog banks, reduces visibility to hundreds of meters or less. For Russian security forces responsible for protecting the Buk-M2's position, the fog was concealment, reducing the range at which Ukrainian ground observation elements could be detected. For the Ukrainian reconnaissance team that conducted the visual confirmation, the fog was a tool, providing cover for their movement to a position close enough to confirm the system's exact location. The reconnaissance team had been tasked specifically with the visual confirmation mission following the electronic intelligence assessment that had narrowed the Buk-M2's location to a general area. They moved during the pre-dawn hours, using the darkness that preceded the fog and then the fog itself as successive layers of concealment. The terrain they moved through, low ground near a drainage feature with vegetation that the mid-April growth had begun to provide as cover, allowed movement to a position within observation range of the suspected location. What the reconnaissance team observed confirmed the electronic intelligence assessment and added precision that the technical collection alone could not provide. The Buk-M2 system, its transporter erector launcher vehicle, its associated radar vehicle, and the support vehicles that typically accompany an operational system, was positioned in a semi-concealed location that used terrain features and camouflage netting to reduce its overhead profile. From the ground, at close observation range, through the thinning fog of the mid-morning hours, the system was identifiable. Coordinates were established with the precision required for a targeting quality fix. The reconnaissance team transmitted their observation and began their extraction. The engagement package that Ukrainian commanders assembled following the targeting confirmation was designed to achieve two specific outcomes simultaneously: destruction of the Buk-M2's missile launcher vehicles, which are the operationally critical components of the system, and destruction of the associated radar vehicle, which provides the target acquisition and engagement control capability without which the launcher vehicles cannot function effectively. Destroying launchers without the radar leaves a partially functional system. Destroying the radar without the launchers leaves launch capability without guidance. Destroying both eliminates the system entirely. The strike package used a combination of drone-delivered precision munitions for the radar vehicle, chosen because the radar's operational emissions made it the easiest component to confirm in real-time targeting, and artillery for the launcher vehicles, whose coordinates had been precisely established by the reconnaissance team's ground confirmation. The coordination of the two strike elements required timing management. The drone engagement of the radar vehicle needed to occur simultaneously with or immediately before the artillery engagement of the launchers to prevent the system's crew from displacing the launchers when the radar strike alerted them to the engagement. The drone that struck the radar vehicle approached through the residual morning fog, flying at low altitude that kept it below the radar's own search altitude band, the same altitude band that the fog had filled with moisture that reduced the radar's effectiveness against low-flying targets. The strike hit the radar antenna mast and the processing vehicle behind it, destroying both the physical antenna and the electronics that processed its returns. The radar went silent. Artillery rounds, launched on a timeline that placed their arrival within seconds of the drone strike, landed on the launcher vehicle positions that the reconnaissance team's coordinates had specified. The first rounds landed on the primary launcher. The secondary explosion from the missile propellant stored in the launcher's ready rounds was substantial. Buk missiles carry significant propellant charges, and the detonation of multiple ready rounds produced an explosion that Ukrainian drone observation teams watching from the edge of the fog bank assessed as catastrophic to the vehicle. The second launcher vehicle attempted to move immediately after the first impacts, the crew executing the displacement procedure that is standard for air defense systems under attack. It had moved approximately 150 meters from its original position when the artillery correction, called by the Ukrainian drone observer who was tracking its movement, caught it on the new heading. The second launcher was destroyed before it reached any position that offered it meaningful protection. The Buk-M2 system, its radar, its two launcher vehicles, its support elements, was gone within minutes of the coordinated strike. The operational effect was immediately observable. Ukrainian drone operators who had been routing around the Buk-M2's coverage area to avoid its engagement envelope found that the radar returns that had been tracking their assets in the sector were absent. The electronic warfare picture that Ukrainian operators used to monitor Russian air defense activity showed the Buk-M2's emissions had ceased. The airspace above the sector it had been covering was open. Ukrainian strike assets that had been unable to operate in the protected airspace began conducting missions within hours of the system's destruction. Observation drones that had been forced to operate at the edges of the Buk-M2's coverage area could now fly direct routes over previously protected Russian positions. Strike assets that had been rerouted around the coverage envelope could now approach their targets through the most efficient flight paths. The operational value of the open airspace materialized immediately in the quality and tempo of Ukrainian air operations over the sector. Now let us examine what Russia lost. The Buk-M2 system, a complete unit including the target acquisition radar vehicle, the command and control element, and the launcher vehicles, represents a procurement cost of approximately $80 to $120 million USD for a full battery in current Russian defense procurement terms. The specific components destroyed in this engagement, the radar vehicle and two launcher vehicles, represent a significant portion of that total system cost. Conservative estimates for the replacement value of the destroyed components, $40 to $70 million USD. This figure places the Buk-M2 in a different cost category from most of the Russian systems discussed in previous Arsenal Hub analyses. It is not a tank. It is not a howitzer. It is a complex, highly integrated electronic and weapon system that requires sophisticated manufacturing, precision components, and specialized personnel to operate. All categories that Western sanctions have directly constrained for Russian defense production. The production capacity for Buk-M2 systems in Russia is limited and currently operating under the same sanctions pressure that constrains all Russian precision manufacturing. The microelectronics, radar processing components, and precision guidance systems required for a Buk-M2 are not mass-produced items that can be readily substituted. The replacement timeline for a destroyed Buk-M2 component under current Russian production conditions is measured in months to years, depending on the specific component and the current state of the relevant production line. The crew losses associated with the system's destruction represent a personnel cost that compounds the materiel figure. Buk-M2 operators are air defense specialists, with training requirements that exceed standard artillery or infantry qualifications. The radar operators, the fire control officers, the launcher crew members who understand the system's engagement procedures. Each represents a training investment of 2 to 3 years and an operational experience level that cannot be quickly replicated. Their loss is felt not just in the specific system that was destroyed, but in the training pipeline and the expertise base of Russian air defense forces more broadly. The operational cost, the opening of the airspace that the system was protecting, is the most immediately consequential dimension of the loss. Ukrainian air operations in the sector have changed character following the system's destruction. The observation coverage that Ukrainian drones can now provide over previously protected Russian positions gives Ukrainian commanders intelligence about Russian logistics, positioning, and activity that was previously unavailable or available only at higher risk. The strike assets that can now approach through the open airspace have greater flexibility in their route planning and can achieve higher effectiveness against targets that were previously protected. The Russian unit responsible for air defense in the sector must now either redistribute coverage from adjacent systems, creating gaps elsewhere in the air defense architecture, or accept the reduced coverage until replacement assets can be sourced and positioned. Neither option restores the pre-strike situation. Adjacent systems that are redistributed to cover the gap are covering their own sectors at reduced effectiveness. Replacement assets that are sourced from theater reserves reduce the reserves available for other urgent requirements. The Ukrainian reconnaissance team that moved through pre-dawn darkness and mid-April fog to establish targeting coordinates for this strike accepted real risk to do so. Moving on foot through terrain that Russian security patrols cover at close observation range of a high-value air defense system whose security element was alert to exactly the kind of ground reconnaissance threat they represented, under fog conditions that reduced mutual visibility for both sides simultaneously. This is not a low-risk operation. The team completed it, transmitted their confirmation, and extracted before the strike that their observation enabled was executed. Their work, and the work of the drone operators and artillery crews who executed the strike, opened a section of eastern Ukrainian airspace that Russian commanders had been using to protect their rear area operations. That airspace is now Ukrainian operational space, available for observation, available for strike, available for the Ukrainian forces who are using every advantage they can develop to hold the front and degrade the Russian force that is trying to break it. The fog thinned, the radar went silent, the launchers burned, and the airspace that a Buk-M2 had been protecting opened to Ukrainian operations that were already waiting for it. Ukraine finds what Russia hides behind its shields. Ukraine removes the shields. Ukraine uses the space those shields were protecting. And the front holds under skies that belong to Ukrainian defenders now. To understand the full significance of this engagement, it is necessary to examine what air defense means in the specific operational context of eastern Ukraine, and why the destruction of a Buk-M2 system has consequences that extend far beyond the immediate materiel loss. The competition for control of the airspace above eastern Ukraine has been one of the defining dynamics of this conflict from its beginning. Neither side has achieved the kind of air dominance that conventional military doctrine associates with decisive air power. Russian aircraft cannot operate freely over Ukrainian-controlled territory because Ukrainian air defense systems threaten them at the ranges required for effective strike operations. Ukrainian aircraft cannot operate freely over Russian-controlled territory for the same reason. The result is a contested airspace environment in which both sides operate with extreme caution, and in which the balance of air defense effectiveness on each side directly determines what kinds of aerial activity are possible and what are not. In this contested environment, drone warfare has emerged as the primary form of aerial combat, not because drones are the preferred platform for either side, but because their small size, Low cost and ability to be operated at scale make them viable in an airspace environment where manned aircraft face prohibitive threat levels. Ukrainian FPV drones, reconnaissance platforms, and strike drones operate across the contact line continuously, providing the observation, targeting, and strike capability that neither side's manned aviation can freely provide. Russian air defense systems, the Buk-M2 being among the most capable in the theater, are the principal constraint on Ukrainian drone operations at the altitudes and ranges where those drones provide the most operational value. When a Buk-M2 is destroyed, the specific coverage sector it was protecting becomes available to Ukrainian aerial assets in ways that change the character of Ukrainian operations in that sector. Reconnaissance drones that had been operating at the margins of the Buk-M2's engagement envelope, at altitudes and ranges designed to reduce their exposure to its missiles, can now operate more efficiently through the direct routes that its absence opens. Strike assets that had been routed around its coverage area can now approach their targets through flight paths that are shorter, more direct, and allow higher approach speeds that reduce their exposure to Russian point defense systems. The specific section of the Eastern Front that this Buk-M2 had been protecting is now a different operational environment than it was before the engagement. Russian rear area activities that had been conducted with the confidence that Buk-M2 coverage provided, logistics movements, command post operations, vehicle concentrations, engineering activities, must now be conducted with the awareness that Ukrainian aerial observation and strike assets can operate over those activities without the medium-range air defense threat that was previously present. The behavioral changes that this awareness produces in Russian rear area operations are themselves operationally significant. Russian logistics commanders, who previously moved vehicles through the sector in daylight with reasonable confidence in their air defense coverage, must now evaluate each movement with the awareness that Ukrainian drones can observe and strike them at the altitudes they operate. Russian command post personnel, who worked with some confidence in their overhead protection, must now implement additional concealment and dispersal measures that consume time and resources. The operational overhead of operating without air defense coverage is a cost that compounds daily. Ukrainian intelligence analysts who developed the electronic intelligence picture that identified the Buk-M2's approximate location had been working within a broader air defense mapping effort that Ukrainian forces maintain continuously. Every Russian air defense system in the theater is a priority intelligence target. Its location, its operational patterns, its coverage sector, and its vulnerabilities are all subjects of ongoing collection and analysis. The electronic intelligence that detected the Buk-M2's emissions and developed the directional bearing that guided the reconnaissance team's confirmation operation was the product of that continuous mapping effort. The reconnaissance team's ground confirmation mission, moving to close observation range of a high-value security-protected air defense system through pre-dawn darkness and morning fog, represents a specific operational capability that Ukrainian special operations and reconnaissance forces have developed and employed throughout this conflict. The risk is real and not trivial. Russian security elements protecting high-value assets like the Buk-M2 are specifically tasked with detecting and intercepting exactly this kind of ground approach. The fog that the team used as concealment also constrained their own visibility, requiring navigation by means other than direct observation, and increasing the physical demands of movement through terrain they could not see clearly. The team completed the mission. The confirmation they transmitted was precise enough to support the targeting solution that the fires package required. They extracted successfully. The operational value of trained reconnaissance personnel who can execute this type of mission, who have the navigation skills, the terrain awareness, the noise and signature discipline, and the tactical judgment to approach within observation range of a security-protected target in adverse conditions, is not captured in any unit cost or replacement timeline. It is an organizational capability built through selection, training, and operational experience that takes years to develop at the individual and unit level. The fact that Ukrainian forces have this capability and are employing it routinely reflects the development of a professional special operations and reconnaissance culture that has been one of the consistent strengths of Ukrainian military performance throughout this conflict. The drone operator who flew the precision engagement against the Buk-M2's radar vehicle, approached at an altitude band that was specifically chosen to exploit the fog, staying within the moisture layer that degraded the radar's ability to detect low-flying targets while maintaining enough altitude to approach the target from a useful angle. This was not a standard approach profile. It was a specifically designed exploitation of the environmental conditions that the mid-April morning fog provided. Ukrainian drone operators have developed the meteorological awareness to identify and exploit exactly this type of environmental opportunity. To match their operational approach to the specific atmospheric conditions of the engagement, rather than applying standard procedures regardless of context. The artillery correction that caught the second launcher vehicle as it attempted to displace, tracking its movement from the first impact point and adjusting fire to intercept it before it reached protective terrain, reflects the real-time fires integration that Ukrainian combined arms operations have developed. Counter-displacement fires against a moving air defense launcher require an observer who can track the vehicle's movement, a communications link to the gun line fast enough to transmit corrections before the vehicle moves beyond the engagement solution, and a gun crew capable of adjusting rapidly enough to maintain effectiveness against a moving target. All three elements performed as required. Russia's air defense architecture in eastern Ukraine is not a single system. It is a layered network of systems at different ranges, altitudes, and technical specifications that collectively provide the coverage that Russian rear area operations depend on. When one element of that network is destroyed, the coverage it provided must either be assumed by adjacent systems, which creates gaps in their own sectors, or accepted as a temporary vulnerability until replacement assets can be positioned. Neither response fully restores the coverage, and the time required to develop a replacement response creates a window of vulnerability that Ukrainian forces have demonstrated the capability and the intent to exploit immediately. The Buk-M2 that burned in eastern Ukraine in the mid-April fog was protecting something that Russian commanders valued. They had positioned it specifically to protect that section of the operational area. Ukrainian forces found it, confirmed it through the fog, and destroyed it before Russian commanders could move it to safety. The fog that provided Russian security forces concealment provided the Ukrainian reconnaissance team the same concealment for their approach. In the end, the team that made better use of the fog won the fog. Ukraine uses every weather condition. Ukraine exploits every window the environment opens. Ukraine destroys what Russia uses to protect itself. And the airspace above the eastern front, in the sector where a Buk-M2 no longer operates, is open to Ukrainian eyes and Ukrainian strikes. The front holds. The skies above it are watched by Ukraine. There's one final dimension of this engagement that connects the technical and operational analysis to something more fundamental. The dimension of what it means for the soldiers and civilians of eastern Ukraine, that the airspace above them is contested by Ukrainian forces rather than ceded to Russian observation and strike. Air defense is not only about preventing Russian aircraft from operating. In the context of this conflict, it is equally about enabling Ukrainian aerial assets to operate, to provide the observation that keeps Ukrainian defenders informed about Russian movements, to enable the strikes that degrade Russian capability before it reaches the contact line, and to impose on Russian rear area operations the same overhead threat that Russian air defense has been imposing on Ukrainian operations. The Buk-M2 that was destroyed in the mid-April fog had been protecting Russian rear area activities from exactly this overhead threat. Its absence means that Ukrainian drone operators can now observe Russian logistics movements in the sector, can identify Russian command post activity, can provide targeting data for Ukrainian fires against Russian rear area concentrations that were previously protected by the air defense coverage it provided. The Ukrainian reconnaissance soldiers who moved through the fog, the drone operator who flew through the moisture layer, the artillery crew who tracked the displacing launcher and adjusted in real time, they did not simply destroy a weapons system. They opened a window in the Russian defensive architecture that Ukrainian forces are already using to see more clearly, to strike more effectively, and to hold the front more confidently. That window cost Russia up to $70 million, and a specialized crew that cannot be quickly replaced. It cost Ukraine the airspace it was protecting, airspace that now serves Ukrainian operations. Ukraine finds the gaps in Russia's defenses. When there are no gaps, Ukraine makes them.